NASA's Hubble Space Telescope find a unique kind of supernova blasting a strange white dwarf star across the Milky Way. The star, designated SDSS J1240 plus 6710, lies about 1,430 light-years from Earth, in the constellation of Draco. When a star dies, it ejects its mass in a supernova, and it expands quickly. Eventually, it slows down, forming a bubble of glowing gas, and a white dwarf star emerges at the center. Our sun will one day become a white dwarf, as will more than 90% of the stars in the Milky Way. Astronomers previously thought the white dwarf had an unusual atmospheric composition. The new study found that the star was probably part of a binary star system that survived its supernova explosion. The blast sent it and its companion star flying through the Milky Way in opposite directions. The majority of white dwarfs have atmospheres composed almost entirely of hydrogen or helium. They are sometimes dotted with carbon or oxygen that was once in the core of the star. However, the flying white dwarf star seemed to contain neither hydrogen nor helium. It was instead composed of an unusual mix of oxygen, neon, magnesium, and silicon. Hubble also identified carbon, sodium, and aluminum. There is also a clear absence of the iron group of elements: iron, nickel, chromium, and manganese. The lack of the heavier elements suggests the star only went through a partial supernova before the nuclear burning died out. The researchers also found the white dwarf was traveling about 560,000 miles per hour in the opposite direction that the galaxy is rotating. Moreover, it had an especially low mass for a white dwarf, only about 40% of the mass of our Sun.